This is the Smart Buildings Academy podcast with Phil Zito, episode 367. Hey folks, Phil Zito here, and welcome to episode 367 of the Smart Buildings Academy podcast. In this episode, we are going to be looking at performing effective site audits. We're going to talk about what a site audit is, and we are going to look at 7 tips that you can utilize to have more effective site audits when you go and actually do those. As always, everything will be available at podcast.smartbuildingsacademy.com/367. Once again, that is podcast.smartbuildingsacademy.com/367. And speaking of audits, if you are wondering what you or your team's technical capabilities are, maybe you're finishing up the summer and projects didn't quite go the way you thought they should go, or you've lost one of your top performers and you need someone to step up and be able to do that higher level work, I encourage you to check out our technical skill assessment at podcast.smartbuildingsacademy.com/367. It is a completely free online skill assessment that will pinpoint any gaps you or your team have in the area of building automation. All right, with that being said, let's dive in. So what is a site audit? A site audit, quite simply, is going to an existing site. So that's the first thing, right? An existing site. You're going to go to this existing site with a purpose. Now, typically the purpose for us within this industry has been retrofits. Although with things like, I think it's State Law 76, if I remember correctly, in New York, things like Title 24 in California, things that are coming down the pipe in Washington, D.C., that have massive fines associated with carbon performance and energy performance of buildings. We are starting to increasingly see site audits being utilized not so much as a pure energy audit, but as a hybrid. Like, what building assets do we have? How are they performing? And then how can we optimize them? We see a lot of owners taking inventory of their buildings. We've got more calls into our organization from a consultancy perspective around that in the past couple of months than we have in the past couple of years. So it is something that is very top of mind. But whether it's an energy audit or it's a kind of retrofit site analysis audit, it all comes down to the same things, which are gathering the data, which we'll talk about in this episode, identifying systems, creating what is called a site picture. So a site picture, quite simply, is essentially like old school digital twin, right? Folks talk about digital twins. They talk about how it gives you a picture of what the building is and its performance. Well, a site picture is that, but not as technical and not nearly as costly. We want to make sure that whenever we're doing a site audit, that we do it only to the level of reasonableness based on the likelihood of a sale. Now, I'm going to repeat that, but in a different way. So I'm sure your customers would love you to come and do a complete site audit of their building, tell them exactly what's in it, tell them exactly what's performing, what's not performing, and what they could do to fix it. But if you're not going to get any sale out of this, if this isn't going to generate revenue for your organization, then you need to know that up front so that you most likely don't do the audit. But also, if you're doing the audit as like just a favor for an existing customer, that you put the level of effort based on the return you're going to get. So instead of, like, if you know that a customer has a budget, you know a customer needs to make a change because they're not meeting a carbon goal, they're not meeting an energy goal, they're not meeting a performance goal, whatever it is, then you need to go and say, okay, this person has a budget, so they're likely to buy. This person let me just see real quick. All right, cool. This person has buying signals. Maybe they have a fund already set aside, so I can put more effort into this. If this is a person who has no buying authority, has no budget, nothing, then you might want to consider what level of intensity you use in a site audit, if you do a site audit even at all. That being said, let's dive into the 7 tips. Whenever I go do a site audit, and I've done a ton of them in the past, the first thing I ever do, now I know data lies and a lot of folks are like 50-50 on this tip, but the first thing I do personally is I go and I grab the live system data. And here's what I do. I look at the graphics, I look at the points, I see what's in override, I see what's up, I see what's down, I try to see if there's any trend data. What I'm trying to do is maximize the return on my effort. If I could do an export of the live data on that building automation system, telling me what's running, what's not running, get a snapshot of all the graphics, I can get a pretty good site picture that then I can utilize to verify any assumptions I make while I'm in the field. Because what we're going to see is a lot of these tips require you to put forth physical effort of going into the field, looking at the individual systems. If you're able to offset that effort by getting data in the first place, it just makes life that much easier for you. All right, so let's continue right along. Tip number 2 is to read the equipment plate. Now, this seems super basic, but if you've never done a site audit before, there's a tremendous amount of information that you can get just by reading the model plate that's on the piece of equipment. And what I want you to understand, and I've seen this happen quite a bit, is that people will mix vendors. So you may have a carrier chiller and some other type of cooling tower and some other type of pumps, and that's fine. That stuff works just fine. It's not like residential where you try to keep everything the same just so you can get, that one service tech out. With commercial, stuff's mixed all the time. So the temptation for a lot of newer folks who are reading equipment plates is to say, okay, I've got a carrier chiller. That means I've got this type of pump, this because they carry this product. That might not be the case depending on the mechanical who installed this, or maybe some sort of changes that took place during the life cycle of the building. So you don't want to read one equipment plate and assume that cascades to everything else. But reading that equipment plate will give you several things. You'll be able to identify like capacity. You'll be able to identify capabilities. You'll be able to identify potential integrations that exist. And all of this, once again, is tempered by how likely is the sale to happen. If a sale's to happen and it's very likely and it's tied to energy performance and maybe rebates from a local utility, reading this information probably become pretty important because you're going to need it in order to file rebates. If it's not likely to happen and you're doing a favor for someone, simply going and saying you got a chiller, it's of this type, may be good enough. But with this information, right, we've taken our BAS data, we're building what you should be building, in my opinion, is an equipment schedule, and you should be building a network riser if those don't exist. So the equipment schedule will be like a Excel sheet, system model number, system type, system condition. And we'll come back to system condition in just a second. And then your network riser should be where these controllers are and kind of what they're controlling, and where panels are and what they're controlling. So up to this point, we've got a snapshot of the system, and we've got an idea of what pieces of equipment are being controlled by our system. That brings us to tip number 3, which is one of my favorite tips that I didn't realize until a mentor of mine taught me this. But it's to check the maintenance logs. And I realized, okay, check the maintenance logs, make sure maintenance has been done. That was not what he was teaching me, though. He was teaching me to look at who did the maintenance and what was the maintenance process. So if I went and looked at a maintenance chart, if you went and looked at a maintenance chart, you could say, okay, these filters are changed every 3 months. This fan belt is changed every 6 months, whatever. This compressor was changed back on whatever date. And that gives you an idea that maintenance was done, so the system's likely to be in better condition. But what you should be looking for is who did it. Was it offsite personnel? Is the facility simply ran by, some janitor, and then they have a centralized maintenance staff who come in and do things? So there's not on-staff maintenance. That's going to become important later as we look at how can we best support these customers. But additionally, you start to understand how many of your competitors have come in and performed maintenance on these systems. And that's important because if you're going to be selling, and that's a little tiny nuance that you don't pick up on initially, but if you're going to be selling to this person, you're doing a site audit, it's nice to know who's potentially going to be competing with you. And by looking and saying, oh, this person maintained it, this person maintained it, this person maintained it, you now have 3 potential company competitors that you know what their products are. You should know what their general pricing is. You should know what their go-to-market strategy is so that you can go and mitigate those during the sales process, whether that's mitigation through spec hooks, whether that's mitigation through how you build your architecture, whatever it is, you now have that information. I didn't realize that at first. I was just simply looking to know whether maintenance had been done or not. Tip number 4 is grab schedules, set points, and parameters. Now, this kind of brings us back to the building automation system, but we're going a little bit deeper. I tried to organize these things into level of complexity so that as you become more likely to get a sale, these are things that you can do at a deeper level. So right now you want to grab your schedules. You want to know what's scheduled on. You want to know what set points are being used. Do they have summer, winter changeover set points? Are there resets built in? And what are their parameters? What are their calibration parameters? What are their parameters for alarming and trending? And this is going to give you a good picture of how the system's currently being utilized. Because if you find out that everything's scheduled 24/7, set points never change, there's no resets, all the parameters are set at their default, then you have some like super duper low hanging fruit. If it's an energy play or if it's a performance play, it's pretty easy for you. But additionally, and you always got to cover CYA, right? Cover your ass. You've got to make sure that you are going and capturing this data. Like when I said, make sure you capture what systems are down, you also want to capture set points and parameters because, right, the old saying, it's always control's fault, right? It's always the controls. Well, we also want to go and be cognizant of the fact that who touched it last owns it. So if stuff was never properly calibrated, there was never a good test and balance done, these are all things that you need to go and be cognizant of so that way you can account for them either in your costing, your exclusions, etc. Tip number 5. At this point, everything may look great. Your systems may look like they're running, your equipment may look like it's maintained, and your set points may be being achieved. But there may be some areas that are uncontrolled and uncomfortable. We recently had our company offsite, and my 2 employees that are from the East Coast were joking this morning on the team call about this place called the Devil's Butthole in, I think it was like one of the airports. And it's basically this area that has no ventilation because of how it was designed. The temperature is not controlled well, and it's sucking in all this just stagnant air. And it's just a miserable part of the airport to be in. However, I'm sure if we dug into that airport, there may be temperatures that are being maintained. There may be systems that are performing properly. But if you don't have sensors in the appropriate areas, you may have uncontrolled, uncomfortable areas. And who is going to inherit that design flaw once you retrofit the system? It's going to be you. So always think CYA and realize that if an area is uncontrolled and uncomfortable, maybe there's an office, maybe there's a wing of the building that is, southern facing and not appropriately sized for the solar loads, then you need to be aware of that so that you can address that in your scope and in your retrofit. These are things that you need to cover your butt on, because as soon as that doesn't perform, guess who owns it? Now we're going to go to tip number 6. And tip number 6 is pretty simple. It's profile the energy density. Now you could do this a bunch of different ways. Like I just went and I Googled energy audit data form. And if you do that, you'll get all these DOE, NREL forms, and just pick whichever one works for you, right? But what we're trying to do here is we're trying to understand what is our consumption and demand per square foot. And then we want to be able to compare that to the database of buildings in a like vertical market in our area. And what that will do is that will tell us that this building by and large does or does not perform well. Because you can go and have a building that looks like it's terribly maintained. It just looks awful. But for whatever reason, whether it's set points, whether it's their sequencing, it can perform well. And vice versa, you can have a building that looks immaculately maintained, but due to the tenants, due to the sequences, due to the set points, can be performing poorly. And so what you want to focus in on here is overall energy density. That's how much energy, typically in BTUs. So you'd have to convert your kilowatt hours and your therms to BTUs, but that's typically BTUs per square foot. And you want to know, what is my density for just the general building? You want to know your density for your system performance. Do be cognizant that if you do sensors, and we'll do an episode on sensors, if you do sensors at certain locations on the distribution of wherever the power is going through the building, you may, due to power factor, due to draw, et cetera, you may get improper representation of what the system is actually consuming. I've seen systems that were fed by separate distribution loops, and because of that, it may look like a system is performing well when in actuality that system is not performing well. So we do want to be cognizant of that. Now, this energy density profile, it's going to help you understand, okay, these air handlers are underperforming. So maybe we want to look at sequencing with them, or the total building's underperforming. Maybe there's a pressurization. Maybe there's an insulation. Maybe there's a glazing issue. There's a variety of building envelope things that may be going on. Or maybe we will find that specific areas, while they have great density, so their performance is great, they're uncomfortable. So we've all seen that, where spaces through a tenant finish out, tenant improvement, they get undersized and a space is inefficient or not properly controlling to the thermal comfort that it should, even though it is efficient, is what I mean. Now we come up to tip number 7, which is to log conditional data. So this is where, like hobo sensors, any type of sensor that you can leave and you can log conditional data is going to become important. I'm a big fan of not trusting trend logs and trusting the sensors in any building that is more than 3 to 5 years old. After 3 to 5 years old, systems tend to have degradation of their sensors. Some places you read will say a 1% degradation per year. It depends on if it's an active sensing element like a CO2 or a humidity, or if it's a passive sensing element like a resistive or thermistor. So I think the general rule of thumb is every 5 years you should be replacing your humidity and CO2 and VOC elements because they're like these little membranes. But the RTDs and thermistors, once you get them dialed in, they should hold steady for a good amount of time. That being said, one of the biggest inefficiencies in systems can be sensors, because quite simply, especially if you live in a very humid environment, if you have a sensor that's off with maybe 3 degrees dry bulb, that can be a huge difference in relative humidity and moisture mass that is in the air. And if that is what switches over your central utility plant or your economizer, then you can find yourself introducing large enthalpy loads, large moisture loads that need to be removed from the airstream. Or you can find yourself in areas where your cooling tower doesn't have a good approach due to the improper sensing. Which brings me to, I like to log conditional data, but you may say, Phil, what data? Like, what should I log? Because it doesn't seem feasible to go to an 800-bed hospital, that's a massive hospital, and go there and put a sensor in each space, in each room. That would be ridiculous. But what I like to do at a minimum when I log conditional data is I like to find the points that actually drive the switchover states. So if my outdoor air temp drives my switchover states for my central utility plant, if it drives my switchover state for my economizer, then I definitely want to log that with a reliable, oh my gosh, I used to do this when I was in the Navy too, and I'm forgetting the term for it, but we had a kit where we would actually validate that the sensor worked and was accurate. It'll come back to me probably way after this podcast, but you want to make sure that your logs are not NIST. I feel like it's NIST, but it's not. It can't be NIST, can it? I think it's NIST who does the testing on your logs and says that they are actually certified to be what they are supposed to be. That being said, whoever it is, you want to make sure that your logs are accurate. And then I would go find my outdoor air sensors. I would find my average valve positions if I'm doing some sort of reset there. I would find the temperatures that drive my resets. I would go to my large air handlers and get good pressure readings, make sure my pressure is accurate. I would try to get good flow readings, making sure anything that tends to be a large consumer of utilities, I want to go and find the primary points that trigger those to change states or to enable, and I want to ensure that they are accurate, and I do that with my logs. All right, so those are our 7 tips. Let's go through them real quick. Let's open up for questions, and then I'll close us out. We've got some other really good stuff coming on. On Wednesday, we're going to talk about energy management strategies. And on Friday, I've been getting a lot of questions about KNX. And while I've worked with it in the past, I haven't done a deep dive on it like I did BACnet. Like I went and read the BACnet standard. So between now and Friday, I'm going to try to read the KNX standard. And then we'll explore KNX on Friday together and try to get a better understanding of what it is as a protocol and framework. So site audits, you should do them. I think we're going to see a lot of them coming down the pipe with all these regulations that the municipalities are pushing out upon building owners. I think you're going to see people wanting to get a good site picture of their building. I think you're going to see people wanting to drive energy efficient strategies in their building. And it's a good opportunity if you're like, how can I get a foot into a customer? Definitely a site audit is a way to get in there. And it's a way that, especially if you have a service presence, to drive some retrofit work. And as a building owner, in my opinion, it's something you yourself can do as well to just get a good picture of what you have so that you can make appropriate operational or capital budget decisions. Now, what are the 7 tips again? Number 1 is to use the BAS if possible, right? We want to grab our data, grab our graphics, do a backup, and really understand what's up and what's down. That's going to become important also, especially if we do a site audit and then we do a retrofit that simply involves putting a new head end in and we leave the existing controls, and someone later is like, the controls worked great before you did something. And then you're like, well, no, actually, we have this down system list. You signed off on it saying you agree that these are down. They're still down. It's not our responsibility. So really, CYA. Tip number 2, getting those system model numbers, really understanding what systems are in place. At a minimum, your air handlers, your pumps, your chillers, your boilers, those things, you may not need to get, well, I don't think you should get every single model number for every VAV box. They tend to be typical, but your air handlers, those can be unique. So anything that was engineered, you definitely want to consider getting a model number for that. Check maintenance logs. Not only does it tell you if stuff was done and where stuff wasn't done and what was done, but it also tells you what potential competitors have been in that building or are still in that building, so you don't get blindsided. The worst thing to do is to do this great site audit. You turn it over to the customer and they hand that off to their maintenance company that's already doing work there. And you're just like, I had no clue that this person was doing work here. Well, if you read the maintenance logs, you would have seen that so-and-so from such and such company was doing it. Tip number 4, grab those schedule set points and parameters. Those are going to become important, especially if you do any form of reconfiguration. While I am an advocate of any major retrofit should have functional test, point-to-point checkout, and test and balance redone, in my opinion, I do realize those are costs a lot of organizations do not want to absorb. So at a minimum, grab those box sizes, grab those K factors, grab those min and max CFMs, grab those prop bands, those I values, etc. Grab those schedules, grab those alarm parameters, and document them and put them back in place. Do be cognizant, though, if you use things like PID loop settings or anything, and your manufacturer uses a different set of settings, you may have to reconfigure and retest. Tip number 5, identify those uncontrolled, uncomfortable areas. You don't want to be accused of those areas being uncomfortable and uncontrolled because of something you did. So if you document that, you point out the fact that there was never a temperature sensor in there ever anyways, and the ducts to that area were disconnected in a tenant finish out, then you can go and either charge to fix that, or you can just exclude it in your scope letter. Profile that energy density. Tip number 6, make sure you really understand what the energy density of the overall building is compared to like buildings in your market. Understand the energy density of your individual systems, but do be cognizant that if you look at system level energy, it may not appropriately represent what the system is actually drawing, depending where you meter, whether you meter on load side or not load side, and whether it's being fed by multiple sources or a single source. And then finally, tip number 7, log that conditional data. Make sure you have that data because, and when I say data, I'm talking, in my experience, any data that drives state or mode changes. So an outdoor air temperature sensor that drives winter, summer switchover, a outdoor air sensor that drives economizer enable, valve positions that drive a reset of pressure, temperatures that drive a reset of temperature set points, etc. You want to be logging those sensors and logging that data to ensure that that is accurate. All right, I'll see if we have any questions. As always, everything will be available at podcast.smartbuildingsacademy.com/367. Once again, that's podcast.smartbuildingsacademy.com/367. I do ask that if you found this or previous episodes valuable, please, wherever you're listening to this or watching this, leave a 5-star review and a comment, leave us a like and or a subscribe, and share this with your fellow coworkers, friends, family, whoever you think will take value from this. It helps spread what we do every week for you at no cost. And I recently saw another 5-star rating on iTunes come through, and didn't leave a review, but left us 5 stars. So thank you to whoever did that. Definitely appreciate that. It's a small ask for everything we provide. And if you found our free stuff valuable, I encourage you to check out at podcast.smartbuildingsacademy.com/367. There will be a link to our courses and training programs. Over 12,000 folks have been through our programs across 2,000 companies. And I would encourage you to consider if you have training needs or development needs, to consider using our organization to help you solve those needs. We're vendor agnostic. We don't teach products, but we do teach processes and the core knowledge people need to go and understand how to do building automation work. Thank you, Todd. I appreciate you pointing out how much we do. Thank you so much. And I'll sit here for just a little bit and see if anybody has any questions about site audits. I'm an open book. Like I said, Wednesday is going to be about energy management strategies, and Friday is going to be about KNX. And as I've said, we're still working on getting more guests onto the podcast. We're growing really, really fast. And unfortunately, with that fast growth, at times we have to put stuff to the side, and getting guests on the podcast is usually one of the first things that falls to the side just because of the logistics about it. So, all right, I got a question coming in here from Andrew. What do I do when I come across older systems in place that no one has access to? Not trying to tip off the vendor that has not shown up in years. So the first thing I do when I come across a system that no one has access to, because most folks weren't cyber aware back in those days, is I Google what the default username and password is for that system, and I see if I can log in with that. The second thing I do, because it's typically a physical server, they usually have the graphics stored on the actual machine. So I'll copy the directory in which the BAS software was there, as well as their database, and see if I can't pull data out of the database and out of the file structure. I usually, with older systems, they used like Access DBs or SQL DBs, and they didn't lock them because there wasn't really a cyber threat. So I can tend to pull out a system database and or graphics and get a pretty good idea of what was there. Additionally, I'm always going to look, I didn't mention this in this, but I'm always going to look for O&M manuals. I just assumed that everyone knew. Look for your O&M manuals, look for the control submittals, look for the MEP set, look for the spec set. So I'm going to grab that as well. And then the final thing, like if I'm really feeling squirrely and I have the owner's permission, I can image that machine and just bring it back with me and see what I can do with that image. So those are things I do personally. And when I would do site audits, I would go and you'd be surprised what you can simply find in the file structure of an old system. So hope that helps. Good question, Andrew. All right, let's see what else people have coming in here. I will say, for those of you who are in sales and in service, like right now, seriously, is the prime time to be going and doing this. You're in those shoulder months and people are just starting to do switchover and they're firing up stuff and it's not working. And just your mere presence may put you there at the right time to get a service call or a change order. Additionally, there are a lot of people, a lot of businesses that are just starting to think about they're a year or two away from these. I mean, we're talking $1 million penalties for some buildings in certain municipalities that aren't meeting their goals. Now, like I always say, I don't have a dog in the fight. I'm not getting into the politics of what these sustainability goals are going to do for whoever. But the reality is they're coming, and there's going to be many organizations held accountable to them. And if you aren't having those discussions, one of your competitors most likely is. So you should be trying to have discussions with them around, do you have any sustainability goals? Do you have any carbon goals? Do you have ESG reporting? Do you have consumption or demand reduction goals? Do you have net zero goals for your buildings? What is your plan to achieve these? How are you going to achieve them? Have you done an audit? Do you understand your energy intensity? These are all questions you should be asking, and just letting them talk and listening and understanding the maturity and life cycle that they're building and their organization is in. Because, and that's important, because you may hear someone say, we have energy goals. And then you're like, okay. And they don't go into any detail about energy. So that probably tells you that they may have energy goals, but either that person's not tied to them, and so selling energy to that person's not going to go anywhere, or the goals have not been cascaded down, or they're just not very serious. So sometimes it's in what is not said that is more important than what actually is said. So OMB in Norway says energy management is huge. At the worst, we've paid over $1 per kilowatt hour. That's a lot of money. Very crazy. I could only imagine what would happen if that was in the United States. People would like freak out. And supposedly it's going to get worse. I've heard of like people putting, and I'm not in Europe, so I don't know. It's just what you hear in the news. But I've heard of like countries putting bans on chopping down forests because people are trying to chop down wood so that they can burn and create heat for their own personal homes. And supposedly it's gotten to the point where they're regulating that now. So pretty wild. I think, utilities is just going to continue to be a discussion point. And another thing I want you all to appreciate, if you haven't appreciated it yet, and when I use the words appreciate, that doesn't mean I necessarily agree with something. I just want to put that out there. I mean appreciate as in just take into account the Inflation Reduction Act is going to pump a ton of money into the renewables and into the sustainability space. There was a retrofit. I'll have to look it up again, but there was a retrofit that was increased by several dollars per square foot as part of this bill and was uncapped, if I remember correctly. So that may be something I do an analysis on. I'll do an episode on the Inflation Reduction Act and what it means to us, because there's going to be a big focus on that. Andrew points out that on January 1st, there's going to be electrical rate spikes. He doesn't want to be doom and gloom, but it is on people's minds. Yeah, absolutely. If there's anything you can do, it's probably too late to be honest, but if there's anything you could do to negotiate a 24-month rate structure, then do that. I know personally here in the Zito household, we are looking into battery storage because we have pretty extensive solar. I really wanted to wait for solid state batteries, but we're considering the lithium ion battery storage because just the unpredictable aspects of utility costs. So yeah, a lot of great discussion. Thank you so much to all of you. I appreciate it. And if there is something you'd like us to talk about in the future, let us know. We definitely will talk about that or try to bring on the right person to talk about it. I will tell you one of the things I'm trying to do right now is to get the person who wrote the book Electrify, which advocates for everything being electric by 2030, as well as trying to get the person who wrote the book Fossil Future, which advocates for not electrifying everything and keeping everything fossil fuels. I want to get both of them on the episode and get their counterpoints of view. I personally am somewhere in the middle, but it would be interesting to just hear because I don't logistically see how we can make everything electric, even though I know it's all over LinkedIn. Folks are like, we're going to electrify everything now. I don't know how that happens, but I also don't know how long we can live on a non-renewable power source. So I don't know what the answer is, but I'd like to talk with others. So if any of you are connected to either of those folks, let me know because I would definitely like to get them on the podcast and ask them a series of questions and figure out what it is that I don't know about these topics. Okay, thanks so much, everybody. I'm going to call it for now. I appreciate all of you being here, and I will see all of you on Wednesday, where we will be talking the top, or not top, but 10 energy management strategies that you can implement right now. So thanks so much. Like I said, everything will be available at podcast.smartbuildingsacademy.com/367 in just about an hour. Thanks so much, and take care.